Hi everyone. Today we will understand another very important mechanical test which is ultimate tensile test or tension test of material. The tensile test related to the mechanical testing of steel products is done on a mechanical full section specimen of the material under examination to a measured load sufficient to cause rupture. The international standard to conduct tensile test is ASTM A370. Tensile testing machine is also called UTM, which is Universal Testing Machine. Let us first understand the tensile testing machine. This machine is divided into two parts. This unit is called loading unit and another unit is called control unit. Loading unit has got three crosshead you can see in the picture: bottom crosshead, middle crosshead and top crosshead. Bottom crosshead is mounted on piston and cylinder, and whereas middle crosshead is mounted on lead screw, whereas top crosshead is attached to guide arms. So the middle crosshead can be used to do the manual alignment or adjustment in the spacing while fixing the specimen. Function of the control unit is to control the load which is applied hydraulically. There are two pointers you can see in the dial gauge, black and red. Red pointer is called dummy pointer, whereas black pointer is the working pointer and shows applied load. Working pointer takes the dummy pointer along with it till it reaches to the ultimate tensile load point. Hence, dummy pointer remain its position even though black pointer goes back. So you can see the dummy pointer gives the reading of ultimate tensile load. Value of the load in is given in kilonewton. Now let us also see how the specimen is prepared. You can see in the picture. uh, Specifically for full cross-section specimen, the length of the gauge would be 200 mm. You can see in this picture there are various letters which are used. So I'll give you a brief understanding of those. G is called the gauge length, W is the width, T is thickness, R is radius of fillet, L is overall length, A is the length of a reduced section, B is the length of the grip section, and C is the width of the grip section. Right? So these are the different letters that we use. So we have to prepare the specimen in this line. So in the video we will show a plate type specimen. Such a specimen are used for testing metallic materials in the form of plate, structural and bar size shapes, and also the flat materials. Those flat materials should have the thickness more than or equal to 5 mm. Then only we can go for plate type of specimen. The specimen is also marked, which is called the gauge marking, with the help of a center punch, scribe marks, or we can do it with the ink. Okay, let us understand what are the different tensile properties that we determine through that step. For easy understanding, you can also see the below stress strain curve. You can see here there are three very important points which comes when we are drawing the stress strain curve. The one is yield strength, as I have told you, ultimate strength, and thereafter ultimate strength point. A necking take place in the specimen and a further application of the load will cause a fracture or the rupture. Right. There are some formulas which are also given for understanding or for calculating various attributes. Once we have the readings from those tensile test, you can always calculate stress, strain, Young's modulus, working stress, percentage elongation, percentage reduction in area, yield strength, and ultimate tensile strength. Okay. Now let us see the video that how the test is conducted. Currently, we are fixing this specimen in universal testing machine. Right, moving the crosshead. Now it is already fixed. The load is gradually applied. You can see slowly the working point black pointer has started moving. And when we are continuously applying the load, you can see that black pointer is continuously moving, which is an indication of increasing load. Now it has taken along with its dummy pointer, which is red pointer, along with us. Now this particular point where the pointer stops for a moment is called the yield point. Right. And if we continuously apply the load, it will reach to the ultimate tensile point very soon. Thereafter, the black pointer will go back. Right. So you can see that right now we have reached to the ultimate tensile point. Now the black pointer has started going back. Right. So that means the specimen has attained a maximum load which can be applied on that. Now the further application will result into a phenomena which is called necking. You can see in this sample also load is applied axially and necking will start. Necking is taking place, you can see in the sample, and thereafter it will break with a third sound.